Our last presenter for today is Matthew McKinna, and he worked in weapons propulsion for 8 years on various chemical propulsion technologies. And for the last 3 years, he has been DST modelling and simulation lead on the Advanced Tactical Booster Technologies collaboration, maturing the design of solid rocket motors. Please welcome him.
So I'm sure we've all heard someone say, it's not rocket science. Well, in this case, it actually is. Long range, high-speed strike, responsive access to space, next generation tactical missile systems. What these three future applications all have in common is they demand new rocket motor technologies in order to make them a reality. And that's where you and I come in. The Advanced Tactical Booster Technologies is an ongoing collaboration between DST and the US Air Force Research Laboratory, where we've identified these key technologies and we're maturing them through the TRL 5 to 6. Now, a key part of this success is going to be leveraging the capability and expertise on offer in Australian industry and academia. It's not widely known, but we're in a bit of a rocket renaissance at the moment, and it's being delivered by materials developments from other industries. You've got carbon fibres replacing structural metals and components like rocket motor cases. Multi-dimensional graphites are replacing traditional graphites and tungsten materials in rocket motor nozzles. And you've got optimization techniques that are replacing the old tried and true rule of thumb design methods. It's all about lighter, more efficient designs that are better suited to the rocket motor environment, which is very hot, 3,500 degrees Kelvin or more, it's highly erosive, and it's very corrosive. At the end of the day, we're making systems that are lighter, faster, they can carry larger payloads, and they can perform a wider range of high-performing missions. So with that in mind, there are a number of partnering opportunities we're looking to explore as part of this. Firstly, at the fundamental materials science level, do you work with some of these more advanced materials? Possibly the chemistry of new insulation materials or resin systems for carbon fibres. We have the ability to take those materials and test them in actual rocket motor firings as part of our program. And if promising, we roll them in and we can expose them to US government and the US industry prime contractors. Secondly, cost is extremely important in these type of systems. So we're interested in partnering in order to address Australian innovative manufacturing techniques to use these advanced materials and bring down the cost of doing so. If you can optimise on cost as well as performance, you've got a competitive advantage. And finally, for those of you cut from the same cloth as the Elon Musks of the world, we're looking at ways we can take the capability and the tools and techniques we've developed and apply them into the space and the applications that have been foreshadowed in the Defence White Paper. So in summary, if anything I've said today has piqued your interest, come and talk to us about getting into the rocket science business. After all, it's not like it's brain surgery.